Hi, second year students. It's fresh chapter exercise 5.2. I have already told you the last exercise of the fourth chapter is the gateway towards fifth chapter. Here, a simple question, simple, wonderful applications of differential calculus, or you can say differential equations. Without wasting time, just jot down to our work. Question number one. A projectile is launched vertically upward from an initial height of 129 feet with an initial velocity of 87 feet per second. A projectile is vertically launched from a height of 129 with initial velocity of 87 feet per second. What are the position, velocity, and acceleration functions? Position, displacement denoted by what? Velocity and acceleration we have to find out. Then the remaining parts we will discuss as we progresses. A projectile is launched upward with an initial velocity of 87 feet per velocity. How we can get to velocity? Means integrate acceleration with respect time. Integrate acceleration with respect time to get to velocity. Why? Naturally, when we are throwing something upwards, gravity comes into play. Gravity comes into play. Here, there is a building that is initially 129 feet high. That is, from there, a projectile is launched. A projectile is launched vertically upward with an initial velocity of 87 feet per second. Here, we are at something. We are at a launch pad, we are at a building, we are at the roof of some building that is 129 feet. It is taken for granted given us with initial height of 129 feet and with initial speed of 87 feet per second. When something is going upward, acceleration is tantamount to negative times gravity, and we start our calculation from here. So our acceleration is given by negative gtt. Gravity is always a constant in that case. dt. Integration of dt with respect to t is r1 plus a constant c. It's a very wonderful phenomena to watch. Initial velocity is r 87 feet per second. Initial velocity at the time of the launch when starting t is 0 or vi initial velocity, that is 87 feet per second. 87 feet per second. So I can write instead of velocity 87 negative g, time is 0. So we have determined our c. In that case, c is 87. C is 87. Plug in the value of c here. Just keep on refining the equation, make it a definite equation having less ambiguous constants. Negative gt plus c plus c plus c. Instead of c, we switch over 87 that we have just managed. It is R87. It is R87. Okay, cool. Now that is velocity function. Velocity. Then we are asked position, velocity, and acceleration. Okay, again integrate velocity with respect to time to get the distance displacement function. Again integrate. Again integrate with respect to we have v dt, that is negative gt plus 87 times dt. Okay, velocity means integration of velocity is displacement. Integration of velocity is displacement, or one can take a tiny trouble to write velocity as rate of change of displacement. Velocity can be written as rate of change of displacement with respect to time, and here integrate it will become gt square over 2 plus 80 70 another constant c. Integration of velocity is displacement. Integration of velocity is displacement. So we have displacement something like that is S is given by negative 1 over 2 gt square plus 8070 plus c. Okay. Initial velocity is 87 feet per second. Initial velocity was 87 per second. Utilizing this, we have managed the value of c while we integrate acceleration to velocity. Now velocity to displacement, again there is a constant c, and we have an initial height. Initial height is 129 feet. 129 feet means we are beginning at the experiment or at the time of launch. When time is 0, we have the height 129. So height is 129 feet. At the time of the launch means at initial time, at the initial stage when time is 0. Let's see. Okay, so our constant is 129 in that case. Now we have fully prepared our distance function in terms of time as 1 upon 2 gt square plus 8070 plus 129. It is our distance function or displacement function as or the position function as required. Okay, this is our position function. Position of this projectile is given by this equation. Motion of the projectile is given by this equation. The projectile travels according to this equation. The projectile satisfied this equation according to the given constants. Okay. What about velocity? Now differentiate this. Differentiation of displacement with respect to time, we are going to get velocity. That is minus 1 over 2 g. T square means 2t. 2 to cancel out, not g. Plus 87. Differentiation of t is 1 with respect to t. 129, it's 0. We have minus gt plus 87. That is our ds over dt, or one can write velocity or ds over dt in that case. Okay, cool concept. Again, we are asked to find acceleration. Again, differentiate v with respect to t, or double derivative of this displacement with respect to time. Double derivative. dt square, we have negative g times 1. That's our negative g. It's our acceleration. It's our acceleration as we have at the outset. This is position function. This is velocity function. Velocity, or one can write, in case of feet per second, one can write 32 feet per second. 32. The value of g in feet is negative present there. G means 32 times c plus 87. In case of meter per second, value of g is approximately 9.8 or 10 meter per second square. In case of feet, it is negative 32. Now, so we have managed all the knowns: position function, velocity function, and acceleration function. Position function, velocity function, and acceleration function. Okay, cool. Now we are asked when the projectile will hit the ground and something like this and that. Let me beautify all these equations at one place. Before rubbing this, we have c is 129. Let me manage the things for myself. Okay, and my velocity is minus 32 times c plus 87. Cool. And acceleration is no doubt minus 32 feet per second, whatever the case is. That's my position, velocity, and acceleration. Moving towards part number 2 of the question. When will the projectile hit the ground? When will the projectile hit the ground? When will the projectile hit the ground? Hit the ground. Let me write it down. Mathematically, when projectile hit the ground, when projectile hit the ground, when projectile hit the ground, height is zero. Height is zero. Height is zero. So this, in that case, our distance. This is our height. In that case, this is our height. Distance means there is a distance function, that is height function. It must be zero when the projectile hits the ground. So we have zero, negative 1 upon 2. G means 32 t whole square plus 8070 plus 129. Applying table of 2, we have negative 16 t square plus 87t plus 129 is equal to 0. Now you are a mathematician. Applying quadratic, A is minus 16, B is 87, and C is our 129. Solving for t, we have negative b plus minus b square minus 4ac divided by 2. Okay, cool. Plug in the values. Minus 87 plus minus 87 square minus 4 times a means minus 16, c means 129 divided by 2 times a, 2 times minus 16. So we have t is equal to 87 plus minus 87 square, 87 square, calculator comes into play, 87 square. We have 7569, 7569, that minus plus 4 into 16 into 144. That will become 64 times 129. That is 8256 divided by minus 30. Divided by minus 30 to okay. Making the space for ourselves. Okay. Managing the space to remain within the frame. It's our constant, it's our restriction on us. So we have 87, 8256, then t is negative 87 plus minus, we have 7569, that is 15825. Let me reconcile again, let me verify again. 7569 plus 8256, that is 15825. Okay, negative 32. Square root of that quantity, square root 15825. It is something minus 87 plus minus 125.797 divided by minus 32, if I am not wrong. Look at this. Here we have two solutions. Quadratic always gives us two solutions. If I take positive symbol, then 87 is less than 125. 87 is less than 125. The positive quantity divided by negative quantity, we are going to get t negative. We cannot afford t negative. So taking the negative sign from here, negative, any quantity negative, result is negative, divided by negative, the result is positive. So we have t negative 87, negative 125.797 divided by minus 32. What we get, let's see. 87 plus 125.797. Cool. It is our negative 212.797 divided by 32. Negative 32. Minus cancel out. Divided by 32. We have t is 6.6499 seconds. That is the time when after 6.6499 seconds the projectile hits the ground. The projectile hits the ground after 6.6499, almost 6.65 seconds. the projectile hit the ground. That is the part that we have solved. What is its impact velocity? Impact velocity, impact velocity when the projectile hits the ground. The velocity of the projectile when it hits the ground, when it hits the ground, and that is the time when the projectile hits the ground. Just switch over T in that, we are going to get impact time, part number 3. Impact velocity. Impact velocity is given by RV minus 32T plus 87. Okay, we have 32 times 6.6499. I have written 5 first, sorry, 99. Yes, it is minus 212.7968 plus 87 minus, that is our V is negative 125.7968. The negative sign shows the impact velocity. Negative sign shows the impact velocity. Let me verify again. That is 32 times 6.6499. That is minus 87. Cool, 125. That is our velocity when the with which the projectile hits the ground. That is the impact velocity. That is the impact velocity. Negative shows the impact velocity. And in your book, the answer of this is not written correct. Projectile velocity, and they have given something positive. They have given something positive to be checked. That is the real answer. Impact velocity. Impact velocity is this. This is the time when the projectile hits the ground. Plug in this in the velocity. You are going to get the impact velocity. Okay. When will the projectile reach its maximum height? When will the projectile reach its maximum height? When will the projectile reach its maximum height? It's a cool concept, and you are familiar, I think. That is, it is already 120 at the launch point is 129 feet above the ground. At this instance, when it reaches the maximum height, it stops. The projectile almost halts for a nanosecond time. For a brief sojourn, a little instance, projectile comes to halt, then it starts coming down. Then it starts coming down. At that point, velocity is zero. Velocity is zero to get maximum height. To get max height, when velocity is zero. To get max height. To get max height. So velocity is zero. Velocity is zero, or velocity is given by minus 32 times t plus 87 is equal to 0. Solve for t. Negative 32, it's negative 87, multiplying minus cancel out. Our t is 87 over 32 seconds. 87 over 32 seconds. Let me divide this 87 divided by 32. It's our 2.718 seconds. When after 2.718 seconds, the projectile is at its maximum height. The projectile has attained its maximum height after 2.718 seconds. After 2.718 seconds. How we come to know that? When velocity is zero, projectile is launched from 129 feet high. When at this stage, when it reaches the maximum height, its velocity is zero. At that very moment, at that very instance, velocity is zero. We have putting velocity is equal to zero. We have calculated the time. It is the time when the projectile reaches its maximum height. Projectile reaches its maximum height. Now we are asked to find what is the maximum height. What is the maximum height? What is the maximum height? Maximum height reached by this one is, what is our time? What is our time? 2.718. Just plug in this to get to maximum what is the maximum height of the projectile? It's the time, plug in this one to get to maximum height. RT is 2.718 seconds. So we have S is equal to negative 1 over 2. G means 32. Our time is 2.718 whole square plus 87 times 2.718 plus 129. That is our maximum height reached by the projectile. Reached by the projectile. It will become 16. Let me do this on calculator. 16 time 2.718, its square is negative 118.2 plus 87.2.718, that is 236.466 plus 129 plus 129. Okay, let me add them and subtract. Let me add them and subtract to get to what? Negative, negative 118.2 plus 236.466 plus 129. We are going to get our maximum height reached by the particle is, projectile is 247.266 feet. 266 feet. Don't forget, our projectile has been fired from the height of 129. We are including that 129 as well. That is 247.266. 247.266. 247.266. If you want to get pure max height, you have to subtract 129 from this one. But we are asked to find max height reached by the particle. Max height reached by the particle from ground. It is the maximum height of the projectile from the ground, not from the point of fire, not from the point of fire, not from. If we are finding its height from the point of fire, then we have to subtract 129 from this. We are finding its height from the ground level. So these are the four parts that we have managed to solve. That's our fifth part. Moving towards next question. It has also 2 to 3 parts, but it's a good one. We have already given a displacement type. Position of the particle, position of the object is given by an object has its position defined by S is equal to S means distance, displacement, TQ minus 90 square plus 2040 plus 20. Okay. An object has its position defined by S is equal to TQ minus 90 square plus 2040 plus 20 in feet. What are the velocity and acceleration function? Displacement is given to us. Differentiate this one time to get to velocity. ds upon dt. It's our velocity. Differentiate one time. It will become 3t square. 9 times 2. It's our 18t. Sorry, there is negative. 18t plus 24. Differentiation of t with respect to t is 1. So we have the velocity function as 3t square minus 18t plus 24. That is our velocity function. We are also asked to find acceleration function. Again, differentiate velocity. It will become differentiate velocity with respect time, rate of change of velocity with respect time. It is our acceleration. It will become 6 times t minus 18 feet per second square. If you are interested in the unit, it's feet per second. Okay, cool. We have done with part number 1. Okay. A twist in the tail. Part number 2, the technical one. What are the position and velocity of the object when its acceleration is 6.5? When its acceleration is negative 6.5 feet per second square. The technicality in that case. What are the position and velocity? of the object when its acceleration is negative 6.5. It must have written deceleration, retardation, owing to its negative sign. But its new book give him leniency. Give it a leniency. A is r minus 6.5. Utilize here a is equal to minus 6.5. Get t, then find velocity and displacement, whatever you want. Just connect this dot. Connect this dot. What are the position and velocity of the object when its acceleration is negative 6.5? Acceleration is given by a is equal to 60 minus t. Acceleration it is equal to minus 6.5. It is given to us. A is equal to 60 minus 80. Solve for t. Solve for t. Minus 6.t. It will become negative 18 plus 6.5. Calculator comes to play. 18 minus 6.5. I can manage the symbol myself. Minus 60. It's our negative 11.5. Dividing with 6. Negative 11.5 divided by minus 6 we have. Dividing by 6. So time is almost 2 seconds. 1.91 seconds. 1.91 seconds. 1.91 seconds. That's the time. That is the time. After 1.91 second, our acceleration negative 6.5. After 1.91 second, our acceleration is deceleration at the rate of minus 6.5 feet per second square. Now we are asked to find its position and velocity. Put this value of t in velocity as well as in position vector or displacement function. Position function as well as in velocity. Let's see and find out. Let me write t. Our t is 1.91 seconds. Okay, cool. Now let me get rid of this rest. Calculator comes into play. 3 times 1.91 square negative 18 times 1.91 plus 24, the tiny concept. Our velocity is going to be 0.5643 feet per second when our acceleration is negative 6 feet per second square. Okay, cool. Then we are asked to find also position. Same time 1.91, plug in this position function. Position is given by t cube minus 90 square. I'm writing this position function again, plus 24 times c plus 20. Plug in 1.91 here instead of t. It is the time when the acceleration is negative 6.5. S is negative 1.91 whole cube minus 9 times 1.91 whole square plus 24 times 1.91 plus 20 plus 20. That we utilize the calculator. 1.91 cube s negative 9 times 1.91 square, okay, plus 24 times 1.91 plus 20. So we have our displacement is given by, let me check again, double check, 1.91 whole cube, sorry it's a square, 1.91 cube, 1.91 whole cube. Our answer is 6.967. 6.967. I'm missing the remaining one. Minus 9 times 1.91 square. Result is this times 9. It is 32.8329 plus 24 times 1.91. It is 45.84 plus 20. Now let me add all this. Plus 20, 45.84 plus 20 plus 6.967 negative 44, and this one how much? 44, 45.84. It's easy. Plus 20, cool. 65 point something plus 6.967, cool. 72.807 negative 32.8 32.8329. We have S is our 39.974 feet when our acceleration is negative 6.5 feet per second. That is position, that is the velocity when acceleration is negative 6.5. Finally, find the total distance traveled by the particle from t is equal to 1.5 seconds to t is equal to 7. Just plug in that 1.5 and 7 seconds and add them up. Finally, we have now it's finally put t is equal to 1, t is equal to 1.5. Put t is equal to 1.5. Let me change the marker. 1.5 cube negative 9 times 1.5 square plus 24 times 1.5 plus 20. Calculator comes into play. The tedious work calculation. 1.5 cube. Okay, negative 9 times 1.5 square, cool, plus 24 times 1.5. It's a cool concept, plus 20. Our distance is after the distance after 1.5 second is given by 39.125 feet. What about after 7 seconds? After 7 seconds, put t is equal to 7. Same equation as is given by 7 cube minus 9 times 7 square plus 24 times 7 plus 20. Calculator comes into play. 7 cube. Okay, minus 9 times 7 square plus, plus 24 times 7. Am I right? 7 cube, 9 times 7 square plus 24 times 7. 24 times 7. 24 times 7. Okay, now cool. Plus 20. It's equal to 90. It's equal to 90 feet. Adding both of these, we have total distance is given by 39.125. When our time is 1.5 second, after 7 seconds, it has traveled 90 feet. Adding them up, plus 39.125. That is mine. 129.125 feet approximately our distance at from t is equal to 1.5 to t is equal to 7 seconds. From 1.5 to 7 seconds, this is the total distance traveled by our object. It's my tiny effort to you guys to explain to you some word problems having wonderful applications of mathematics. It's all about self next.